All right, in this video we're going to practice solving quadratic equations by factoring. This is section 5.6. So the first equation says x plus 2 times x minus 3 equals 0. And if you remember from the lesson, the first step to solving a quadratic equation is make sure it equals 0. So this one already does, so we've got that covered already. The second step is to factor. Well, this equation is already factored, so we've got that step covered. The third step is the little equations, when we take our factors and make them equal to 0. So if this times this equals 0, then that follows that x plus 2 must equal 0, and x plus 3 could equal 0. And we solve, that's the fourth step, solve those little equations that you just made. So to solve this, subtract 2 from both sides. We get x equals negative 2. To solve this, add 3 to both sides, and we get x equals 3. So your solution set is x equals negative 2, comma 3. It's a list. Question 2. First step, make sure it equals 0. Second step, factor, already factored. Third step, make your little equations. Well, now this time we have 3 factors, because besides the 2 binomials, we have this GCF out here. And it turns out that this one could equal 0 also. So we're going to have 3 little equations this time. The first one coming from here, x equals 0. The second one, x plus 6 equals 0. And the third one, 2x minus 1 equals 0. This is already solved, so we don't need to do anything there. This one we're going to solve by subtracting 6. So x equals negative 6. And here we have 2 steps. First, add the 1. So 2x equals 1. And secondly, divide by the 2. So our solutions are x equals 0, negative 6, and 1/2. 3 solutions this time. The 3 solutions come from having this extra factor here. On number 3, step 1, make sure your equation equals 0, and this one does. Step 2, factor. Well, this side of the equation is not factored, so that's the first thing we need to do. So you're going to have to go through your whole factoring list while you're doing this factoring, and the first thing you look for is a GCF, which we have here, a GCF of x. And then we factor that out. Now, I'm going to stop right here and say, if you don't know the factoring part, you need to go back to previous lessons and review the factoring, because I'm not going to go through all the factoring steps, because this is about solving the equation. You can go back through the factoring videos if you need to review factoring. Once you're done factoring, you set up those little equations. Okay, and in this equation, we would have x equals 0 coming from here, and x minus 3 equals 0. This one doesn't need to be solved, it's already solved. This one we need to add 3 to both sides, so that we get x equals 3. And so our solution set is x equals 0 and 3. Number 4, the equation already equals 0, so we need to go to the factoring part. There is a GCF here, so we're going to factor out a GCF of 5x. That leaves us with x plus 2. And then we're going to set up some little equations. We're going to use this one first, 5x equals 0. And then from here, we're going to have x plus 2 equals 0. So to solve for x here, we need to divide by 5. Well, 0 divided by 5 is still 0, so x equals 0. To solve for x over here, we're going to subtract 2. So x equals negative 2. And our solution set is then x equals 0 and negative 2. On number 5, our equation equals 0. So the second step is to factor. Now, if you look at this, it might seem logical to distribute and combine like terms and all that here, but if you think about we're trying to factor this and you see the x plus 7 is common here, this is already partially factored because of this x plus 7 being common here. We can just go straight to the factoring without having to distribute. If you distribute and combine like terms, it's not wrong, but you're going to end up doing more steps because then you'll be left with a trinomial that you're going to have to do either AC method or the square root method or something like that on. If you go here just to factoring out the x plus 7 as being common, we'll bring the x plus 7 to the front because it's common. Take it out of both terms, and then we're left with 4x minus 3. And we went straight to the factors. It's the same thing you would have gotten by using another method, just a little bit faster by going ahead and recognizing that this is already partially factored. Now we're going to make our small equations, our little equations. So we're going to have x plus 7 equals 0 and 4x minus 3 equals 0. To solve for x here, subtract 7 from both sides, and we get x equals negative 7. To solve for x here, first we're going to add 3, then we'll divide by 4. So add 3, and then divide by 4. So our solutions are x equals negative 7 and x equals 3/4. On number 6, the first step, make sure it equals 0, and this one already does. The second step is to factor. And again, your first impulse might be to combine these like terms, and it's not wrong if you do. But then you're making a trinomial, which is fine. You just have to use either AC method, square root method, trial and error, whatever method you know how to factor a trinomial that has a lead coefficient of not 1. Otherwise, you can do what I'm going to do here, and since it's 4 terms, I'm going to cut it in half and factor by grouping. You get the same answer either way. When you're factoring by grouping, you're just using GCF multiple times. So what's the GCF of these two front terms? 4x. We're left with 2x plus 3. Bring down the middle sign. The GCF of these two terms is 5. And we're left with 2x plus 3. Which means this 2x plus 3 is common. So similar to number 5 that we just worked previously, we can bring the 2x plus 3 to the front here, and it's gone. We're left with 4x plus 5. So once we have this factored, we're ready to set up those smaller equations. The first one being 2x plus 3 equals 0, and also 4x plus 5 equals 0. These are both two-step equations. Subtract the 3, divide by 2. So that will give us 2x equals negative 3, divide by 2, x equals negative 3/2. Subtract the 5 on this side, we get 4x equals negative 5, divide by 4, x equals negative 5/4. So our solution set, x equals negative 3/2, comma, negative 5/4. All right, on this page we have 6 more practice problems here. Factoring quadratic equations by factoring. Solving quadratic equations by factoring. So this already equals 0, so we just need to factor, and this is a standard trinomial. The lead coefficient is 1. So we can factor this all in one step. If you remember these steps, again, if you don't remember the factoring part, you're going to need to go back and review a previous lesson. We're looking for two numbers that multiply and make 30, add to make 11. That would be 6 and 5. So those are our factors. We make our little equations equal to 0 from those factors, and we solve those. On this one, x equals 6, and on this one, x equals 5. So our solution, x equals 6 and 5. On number 8, first step is always make sure it equals 0, and then we factor. Now, if you remember from your factoring with two terms like this, there is no GCF here. This is what we call the difference of squares. To factor the difference of squares, we take the square root of the first term, the square root of the second term, and we have 1 plus and 1 minus. And now we're ready to make those small equations. X plus 10 equals 0. X minus 10 equals 0. So x will equal negative 10 and positive 10. So that's our solution set. On number 9, when you're solving a quadratic equation, the first step is to make sure it equals 0. And then we factor. All right, well, because of this, it would be nice if this 12 was common. We could get it off with a GCF, but it's not. So I'm going to use the square root method. That's my preferred method. There are other methods to do this. The square root method says take that 12 and multiply to the first and the last term. So we're going to multiply by 12. Our equal 0 is just going to hold off over here while we do our factoring. So we have 144x squared minus 17x minus 60. 12 times 5 is 60. This is a 12, not a 2. There we go. The next step is to square root the first term. So the square root of 144x squared is 12x. Put your signs in. They're going to be negative, positive. So we're looking for factors of 60 that subtract to make 17. Factors of 60 that subtract to make 17. So I think we're going to have to make a list here. So what do we have? 60 is 1 times 60, 2 times 30, 3 times 20. Oh, there they are. 3 and 20. Subtract to make 17. Write the biggest one first. And then we divide by the GCF. The GCF of these two terms is 4. The GCF of these two terms is 3. So divide both of these by 4. We get 3x minus 5. Divide both of these by 3. We get 4x plus 1. And that's just the factoring step. That's step 2. Because don't forget, we're not just factoring here. We're solving. Step 2 is to factor, so all of these steps are in the factoring. Step 3 is to make your little equations equal to 0. So I'm going to scroll up a little bit here. The first equation, 3x minus 5 equals 0. The second equation, 4x plus 1 equals 0. And we're going to solve both of those equations. And when you get to this part, if you don't know how to solve these linear equations, also you need to go back to previous lessons. And the lessons for solving linear equations are in Chapter 2. So go back to those if you need to review. Add 5 to both sides. And then divide by 3. X equals 5/3. Subtract 1. And divide by 4. X equals negative 1/4. So x equals negative 1/4 and 5/3. So positive 5/3. That was question 9. So we're going to move on to question 10. All right, the first step is to make sure your equation equals 0 when you're solving a quadratic equation. This one does not equal 0. So this is where we come to our first problem. We can't use the zero product property. When we look back here, making these two binomials equal to 0 is part of the zero product property. If this times this equals 0, then this has to equal 0, and this could equal 0. If it doesn't equal 0, you can't use the zero product property. So your first step is to make this equal 0. Not a hard thing. You just subtract anything that's on this side. 2 minus 2 will give us an equal 0. But to do that, remember, I have to do the same thing on the other side of the equal sign. So I'm aligning it under the 30 because they're like terms. So our new equation is x squared minus 4x minus 32. Because negative 30 plus negative 2 makes negative 32. Now my equation equals 0. Now I factor this side. This is a standard trinomial. So the factoring should go one step. X times x, negative, positive. Factors of 32 that subtract to make 4 are 8 and 4. Now I make my little equations. X minus 8 equals 0. X plus 4 equals 0. X equals 8. X equals negative 4. And so we have a list. Your solution set, x equals negative 4 and 8. Number 11, we have a similar situation where our equation is not equal to 0. Not a big deal. We're just going to subtract this term off. So we'll subtract off 11x. We'll subtract off 11x on the left side also. That will give us an equal 0 here. However, the 11x you have to be careful with over here because it's not like terms with either of these. So it's just going to fit in here somewhere. These all three terms are we're going to make a trinomial out of this because none of them are like terms. They cannot be combined. And as I write this trinomial, I'm going to put the terms in descending order. So the first term should be 6x squared, then the negative 11x, then the negative 10. And now we can see we have a trinomial here that we know how to factor. And yes, this 6 is causing us to have to use the square root method on it. So we're going to multiply the first and last terms by 6. So 36x squared minus 11x minus 60. My equal 0 is hanging out over there. Square root the first term. We'll have 6x times 6x. Put your signs in. What are the signs going to be? Negative and positive. So I'm looking for factors of 60 that subtract to make 11. And you can make a list if you need to off to the side. I know that they're 15 and 4. And then divide. The GCF of these two terms is 3. The GCF of these two terms is 2. So 2x minus 5, 3x plus 2. All right, that's just step 2. That's just the factoring. After you do the factoring, you still have to make your little equations equal to 0 to solve. So 2x minus 5 equals 0. 3x plus 2 equals 0. You have 2 steps of factoring. Add 5. And then divide by 2. So x equals 5 halves. Over here, subtract 2. And then divide by 3. So our solution set, we're going to write down here, x equals negative 2/3 and 5 halves. Now, I do realize that I am going through these steps very quickly. These are video solutions for you. You can pause the video anytime you need to catch up whatever you need. Pause the video and go slower if you need to. Okay, number 12, 14x cubed plus 19x squared plus 5x equals 8x. Again, it doesn't equal 0. So we're going to subtract this 8x, and that will give us an equal 0 here. We have to do it on both sides of the equal sign. Remember, those are the rules for any kind of equation. So we'll end up with 14x cubed plus 19x squared minus 3x, because 5x minus 8x gives you negative 3x. Okay, so now it equals 0, and now we need to factor. It looks like there's a GCF here of x. So when we factor out that x, we'll have 14x squared plus 19x minus 3, which gives us a trinomial here that we can use the square root method on. So the first step of the square root method. Now, this x is going to hang out. It's still there. We're not going to work with it right now. We're just going to work with this trinomial. 14 times 14 is 196. 14 times 3 is 52. Not 52, 42. So now we square root this term is going to give us back the 14x. the first sign, the second sign. So we need factors of 42 that subtract to make 19. You might need to make a list over here. So 1 times 42, 2 times 20. Oh, there we go. 2 times 21. When you subtract 21 and 2, you get 19. Now we're going to divide by the GCF, which here is 7 and here is 2. And that's really good because these are supposed to multiply to make the number you started with, which was 14. Divide these both by 7. We have 2x plus 3. Divide these both by 2. There should be an x there. We should have 7x minus 1. All right, and our GCF from way up here needs to come down. All right, these are the factors. So that was step 2, the factoring part. Step 3 is make your little equations. So we're going to have 3 equations this time because of this GCF out here. And that's going to be the first equation, x equals 0. And then 2x plus 3 equals 0. And then 7x minus 1 equals 0. This equation, already solved. No big deal. We don't need to do anything there. Here we're going to subtract 3 and then divide by 2. So 2 steps here gives us x equals negative 3/2. Here, add 1, divide by 7. So this is another 2-step equation. And we get x equals 1/7 out of that. So our solution set, I'm going to try and squeeze it in down here at the bottom. X equals 0, negative 3/2, and 1/7.